This video lesson is going to start with a brief review of the cell cycle, focusing on the differentiating chromatids and chromosomes, and move into a discussion of haploid versus diploid cells, and then a brief review of mitosis as it relates to 2N diploid cells. Mitosis. And in interphase, you have S phase, G1, and G2, or G1, S phase, and G2. All right, now, what happens in S phase of interphase? Synthesis of, not protein, DNA, replication. So during S phase, you've got replication of DNA. All right, now, when a cell comes out of mitosis, the sister chromatids have been split, right? So I'm going to simplify this with, I'll just use a single chromosome just to simplify it. So let's say these two have resulted from mitosis. Now we're going to look just at this one. What's going to happen during G1? Growth and additional organelles, that type of thing. Then what happens in the S phase? We just said replication of DNA. So at this point, this chromosome here, this is still a chromosome, is going to get a copy or a sister chromatid. This is still a single chromosome. It just has a sister chromatid copy. This is a chromosome. This is a chromosome. So I'm going to add some color. I don't understand what you meant, but now I do now with her. So let's say this was our original. Here's our original. And so the copy is represented by the black. All right? But that's still a single chromosome. It was replicated in S phase to have a sister chromatid so that once it moves through G2 and re-enters mitosis, those chromatids can separate in anaphase. Is a chromosome. This is a chromosome. All right? Okay. The other thing that I think can be confusing. Did you have a question, Bradley? No? Okay. So what then is 2N diploid versus 1N haploid? What is the human diploid number? Damien? 46. And the haploid number? You had it. 23. How many chromosomes do your body cells, with the exception of your eggs or sperm, how many chromosomes do your body cells contain? 46. So this is body cells. What do we call the sperm and egg cells?
Gametes.
Sex cells or gametes.
So does N, does the variable N represent the haploid number?
Yes.
And why does it say 1N haploid?
Because 1 times N is still N. It just helps designate. I've always seen it designated that way. It could just say N, but I've always seen it 1N. I think that's how the book represents it. It just always seems to be. I guess maybe to make the distinction. All right. Now, taking this back to chromosomes. In order for a cell to be diploid, it has to have homologous pairs, which means it has to have chromosomes represented from both mom and dad, maternal and paternal. We'll say we're going to have a simple cell, 2N equals 4. Stereotypically use blue for the male chromosomes and pink for the female chromosomes in this case. Now, is this a 2N cell diploid or 1N haploid? Does it include homologous pairs?
Yes.
Yes. Does it include both maternal and paternal copies for each chromosome?
Yes.
Yes. So this is diploid.
So So does a human...
Now, I'm not going to show crossing over. We're getting ready to look at that in a lot of detail. But I want to show you what happens next, just to make sure that we have this whole diploid haploid thing under control. So I'm not going to show crossing over yet. Let's say the first round of meiosis happens here. What separates in the first round of meiosis? Homologous pairs. So,
Oh, because we're talking about meiosis.
okay, now, is this cell diploid or haploid? Haploid, yes, because it does not contain both the maternal and paternal copies of the homologous pairs.
Do we need to show the difference of the paternal and maternal?
When you draw a chiasma, you do need to indicate the different chromosomes, yes, in crossing over. Shading means more not adding shading for dimensional detail in a drawing than providing a distinction between two different things. Does that make sense?
So those two cells are at the end of meiosis 1, right? Like,
Look quickly back at mitosis. Let's go back to our 2n equals 4 example. I'm going to stick to my blue and pink designations. All right, so here's our cell. And this cell gets a copy of the chromosome of each from dad and a copy of each from mom. During the S phase, those replicate. And that leads to, and now it's ready for division.
Not to be confusing, but this mitosis, are we still dealing with parent cells, or is it just...
Otherwise, they're not going to understand the answer to the question how you would have both in the somatic body cells. All right, so we have two homologous pairs here. I'll even underline one, or I'll put centromeres on this one in this color so you can follow this homologous pair. And the other one, I'll put centromeres of this color so you can follow that homologous pair without me having to constantly get the sizes a certain way. So you've got two homologous pairs of chromosomes here. Do you see that? In mitosis, you want to make an exact copy, yes? So in metaphase of mitosis, they line up like this. And then they're going to separate like this. Now, technically, I just want you to be able to follow the pairing. So technically, the centromere's been split, but this helps you follow the pairing. Yes, do you see that? And so then, once those cells split, in the interest of time, we'll just go ahead and take them through telophase and cytokinesis like that. Then when they re-enter the S phase, you've got two copies. Like that. This is the same homologous pair as this. Do you see that? It's just arranged differently. Now, does that answer the question of how, did that answer your question, Kyle, of how somatic body cells, they still are diploid?
I wasn't thinking about replication.
So that helped?
Yeah.
Okay. Any questions about this now? This was mitosis. I was just showing you how that works to help, again, clarify the understanding of what's in the body cells, why they're diploid, and how that process rolls out. But I did record that, so now we'll have a video of mitosis as well. Yes? A simplified one.
If the diploid cells...
So you stay diploid for the entirety of mitosis. So even when, let me go here, before these enter S phase, you still have the paternal chromosome and the maternal chromosome for each homologous pair.
Right.
That is what makes it diploid. The sister chromatids are just simply copies.